Resonance is nothing but delocalization of pi electrons or lone pairs, which will give rise to a resonance structure. Okay, or shifting of pi electrons from one carbon atom to the adjacent carbon atom will give rise to a resonance structure. If you take an example, that is benzene, which is containing alternate carbon carbon single bond and a carbon carbon double bond. Okay, these are involved in conjugation, where the double bonds are shifting that in between carbon carbon single bond, okay, in a cyclic manner. Okay, if you observe that in structure 1, the double bonds are in between C2 carbon and C3 carbon, and next that is in between C4 and C5, in between C6 and C1. Okay, similarly if you observe that double bonds are in structure 2, that is in between C1 C2 C3 C4 C5 C6. Okay, if you draw the resonance hybrid, okay, here the electrons are involving in a cyclic manner, so that's why we will be draw the circle in the inside the ring, where the electrons are in between six carbon atoms. Okay, this is nothing but the resonance hybrid. Okay, similarly if you take an example, that is a 1,3-butadiene, where the double bonds are in conjugation in between single bond and double bond. If you observe that here the two possible resonance structures are there. First, in 1, 2, 3, 4 carbon atom. Okay, the charge will be shifted between that first carbon and fourth carbon. Okay, if you draw the resonance hybrid, the resonance hybrid will be look like this. Okay, thank you. Now let us discuss the conditions of resonance. If all structures have formal charges, the most stable one is that in which positive and negative charge resides on more electropositive and more electronegative atoms. Okay, next step. Neutral species is more stable than that of the charged ones. Energy of resonance hybrid is always lower than that of the canonical structure. All the resonating structures must have the same or nearly same arrangement of atomic nuclei. Next step, resonance structures must have same number of paired and unpaired electrons. However, they differ in the way of distribution of electrons. Okay, it must be planar. It must satisfy octet rule. Octet rule. Types of resonance interactions. Okay, first one, if you observe that pi sigma pi interaction. If you observe the example, that is a 1,3-butadiene. In 1,3-butadiene, we observe that pi sigma pi type of interactions. Okay, if you see that in the next two example, that is a lone pair sigma pi interaction. Lone pair sigma pi interaction. Example, if you take that pyrrole having that lone pair sigma and pi interactions. Next example, if you observe that pi sigma positive charge resonance, pi sigma positive charge resonance interactions. Example, if you take that allyl cation. Okay, allyl cation. Okay, next example, pi sigma negative charge resonance interactions. If you observe that the example, there is a allyl carbanion. Okay, allyl carbanion. Next one, pi sigma free radical resonance interactions. If you take an example, that is allyl free radical. In allyl free radical, we observe that pi sigma free radical type of resonance. Okay, last one, there is a positive charge lone pair resonance interactions. If you see that in this case, the lone pair of electrons will be shifted towards a positively charged carbon atom, which is an electron deficient. Okay, as a result here, both are attaining octet configuration. Both are attaining octet configuration. To attain stability, these involve in the resonance. Okay. Applications of resonance. As the resonance increases, stability of the molecule increases. Hence, its reactivity of the molecule will be increased. As the resonance increases, acidity of the molecule also increases. Okay. If you see that in the next step, as the resonance increases, basicity of the molecule will be decreases. Okay. Resonance affect the bond length. Okay. Resonance affect the bond length. Okay. Resonance also affect its reactivity. If you see that, observe the PYQs which have been asked in the previous JEE questions. Okay, first question, that is acrylaldehyde. Okay, the question is here, the resonance structures possible are 2 and 3. 2 and 3 are the resonance structure that are possible from the original molecule, that is 1. If you compare that, structure 1 is more stable than structure 2 and 3. This is due to more covalent bonds are present in the structure 1. In between 2 and 3, 2 is more stable than 3. This is due to that negative charge is present on the more electronegative atom and the positive charge is present on the more electropositive element, that is a carbon atom. Hence the order of stability is 1 is more stable than 2 is more stable than 3. Okay, if you observe that in the next question that have been asked in the January JEE 2026. Okay, now the from the following the least stable structure. Okay, if you observe that in these structures, which is the least stable structure. Okay, here the third one is the least stable structure because both the positive charge are side by side. Okay, because the same charges will be repels, hence the instability will be generates. So least stable because here is third option. For more videos, follow our channel. Thank you.